Okay, the last question from section 2 that Miss Davis sent me was 2.11. So let's take a look at this question. 2.11 is at the top of the next page. It says, at this very moment, you are giving off electromagnetic waves with a wavelength of about 9 times 10 to the negative 6, I'm sorry it printed that way, meters. Now, in parentheses, quotation marks, it's telling you this is 9 micrometers. Guess what? It's just being fancy. It's just giving you the name of this. This is micrometers. 10 to the negative 6 happens to be micrometers. Now, just so you know, micro, the symbol is mu. Yeah, it just looks like a couple of swirly lines, but this is the symbol for micro. It is a Greek letter. Okay, you'll find it on your gold sheet on the back side with the metric system. However, you don't actually need to do any conversions. It's already converted for you. 9 times 10 to the negative 6 is in meters. So we don't actually have to convert anything. This is just being silly by telling us this is micrometers, and I know that's going to throw people off, but you have to learn to look through the information given to you and decide what's important and what's extra stuff. Okay. Letter A says, what is the frequency of these waves? So we're looking for frequency for part A. And part B, to what portion of the electromagnetic spectrum do these waves belong? Well, we'll take a look at that once we're done with calculating the frequency. All right, so let's take a look. Given and find. I know that my lambda, my wavelength of these electromagnetic waves is 9 times 10 to the negative 6 meters. The fact that these are micrometers really means nothing to me for this math, okay? And we're talking about light again, and we're talking about light with lambda, so we know we have to assume C is 3 times 10 to the 8th meters per second. We're always going to use that speed unless we're told otherwise. We're trying to find frequency for part A. This is for part A, and then part B wants to know which electromagnetic wave it is, okay? So again, C equals lambda times F. I'm going to plug in 3 times 10 to the 8th meters per second for C. That's my speed of light through a vacuum or air. Lambda was given to me as well. 9 times 10 to the negative 6 meters. That's the unit I need, so everything cancels. So see, we didn't even have to do any conversions. What an easy problem. And we're multiplying this by frequency. Frequency is what we're looking for, so we're going to leave F right there. That's the variable we're solving for. You guys have done plenty of these problems. You know what's next. We're going to divide. What we do to one side, we have to do to the other side. Oops. You can tell it's been a little while since I've been teaching. Okay, writing letters everywhere. And then we're going to take this and plug it into our calculator. So here we go. There's my work from the last problem. So 3 shift log 8. Okay, I guess it's not going to type what I'm putting. Shift log 8. There we go. Divide 9 shift log negative 6, not minus 6, negative 6. Make sure you use that negative button. And notice how I was looking at my screen as I was typing things in. Sometimes you guys just type, type, type. Don't double check your work before you click enter and then wonder why you're getting the wrong answer. Sometimes we're pushing the buttons, but it's a calculator, it's a device. It's going to have some flaws, okay? All right, we're going to click enter, and we get 3.33333 times 10, there it is, very tiny, to the 13th power. Okay, so that means lambda, oh my goodness, frequency, F, is 3.33 times 10 to the 13th power. And that's going to be in hertz because this is frequency. Okay, so what if I could look up electromagnetic waves, frequency of 3.33 times 10 to the 13th hertz. What is it going to tell me? I'm looking for, Well, I thought it was going to pop right up. That's okay. We'll take a look at the spectrum instead. Electromagnetic spectrum with frequency. Okay, let's take a look at the picture instead. This one looks pretty good. Yes, this is good. Okay. Oh, come on. There we go. Okay, we're in the times 10 to the 13th power, okay? So this is times 10 to the 4th, times 10 to the 8th, times 10 to the 12th, times 10 to the 15th. Here's where visible light is. We're not quite there. We're in between 10 to the 12th and this red color right here. And if we take a look, that's infrared, okay? We emit infrared, and that makes sense as humans. We emit infrared. So we come back over here, and conceptually we can say this is infrared wavelength and frequency, okay? That is 2.11.